Hi, today I'm going to show you how to use lithium-ion or lithium polymer batteries in your project safely. Lithium-ion and lithium polymer batteries are great batteries for portable power, but if you don't use them properly in your projects, they can catch fire or explode. And if you don't charge them properly or protect them, they can catch fire, explode, or lose significant capacity and become unusable. So to prevent these, you can use a simple board like this. This is called a TP4056 battery charger and battery protector circuit. They have two versions of the circuit. This one is the one that has the protection circuit inside of it. But there is also another version of the circuit, which is like this. As you can see, this version of the circuit doesn't have any of the protection chips on it. But this circuit that I'm reviewing right now has these little two chips on it that protect the cell. And you might have noticed on this board, there is battery plus and battery minus for mounting a battery. But on this board there is also output plus, output minus, and battery plus and battery minus pins. So there are 4 pins on this chip. That way, if you connect output plus and output minus to your project, if there is a short circuit in your project, or if your project doesn't cut the power when the battery voltage goes down below 3 volts, these two chips will automatically do that job for you. But on this board, they don't have those protection chips, so this board is only for charging. But this board can also charge and protect your lithium-ion or lithium polymer batteries. This chip is special for charging lithium-ion and lithium polymer batteries. But this chip can only charge lithium-ion or lithium polymer batteries with only a single cell. What does that mean is they can only charge up cells that are 3.7 volts. Any higher than that, like connected lithium-ion or lithium polymer batteries connected in series, will be 7.2 volts and it can't charge those. There is a TP4056 chip on the board and a DW01 battery protector and an 8205A MOSFET. The DW01 and 8205A MOSFET protects the battery from low discharge, overcharge, and short circuit. The TP4056 charges the battery in CCCV mode. What does CCCV mode mean, you might ask? And that is the charging protocol used in lithium-ion or lithium polymer batteries. To better explain the CCCV or constant current, constant voltage charging technique, we can look at the TP4056's datasheet. Here you can see a graph of a TP4056 charging a 1000 mAh capacity battery. It's also a single cell battery. So as you can see, there is 3 volts here, and there is milliamp hours here, there is voltage here, not milliamp hours, let me correct that. That is milliamps, not milliamp hours, not to confuse with milliamp hours. Here is 3 volts and 200 milliamps. This TP4056 has a function that if the battery falls below 3 volts, which is the safe limit for lithium-ion or lithium polymer batteries, if you discharge them below 3 volts, they might lose some capacity. So when the TP4056 detects that it's connected to a cell that has a voltage below 3 volts, it starts charging at only 100 milliamps. And when the cell that's connected to the chip reaches above 3 volts, as you can see, it slowly rises the current to around 850 milliamps. And then it completely goes on the max charging, which is 1000 milliamps or 1 amps, which is the most that the chip can handle for charging cells. And then, as you can see, there's hours for the charge, and as you can see, there is 4 volts on there. And when the cell reaches 4 volts right here, it goes on to constant voltage mode, and it charges the cell up to 4.2 volts with the constant voltage mode. So that's how CCCV or constant current and constant voltage mode works on a TP4056. Normally, cell phone batteries like these have, or they should have, some protection built inside them already. For example, this is a protection board, small little protection board from a 50 mAh battery, lithium polymer battery. That battery was broken, so I just removed the board from it and recycled the battery that was puffed. So here is two chips on this little board, and one of them is a similar chip to a DW01, which is a battery protection chip, and the other one is probably a dual MOSFET or a single MOSFET used for switching the output and input. So these two chips are basically the BMS, or the battery management system of the battery. As I said, normally cell phone batteries should have a protection circuit built in them that can cut the battery's output when they're overcharged or over-discharged, or when they're too hot. They normally a good cell phone battery should also have a temperature sensor built in, and this third pin in the batteries, cell phone batteries, are usually used for temperature sensing of the phone. But since this is a knockoff Nokia BL5C battery, it doesn't have any of that. So this is just a bare cell, and what they do on this third pin to fake the phone into thinking that it has a genuine battery attached to it, since they use an NTC or PTC on the third pin connected to the negative, they just connect a 2K resistor in the minus part of the battery and on the third pin of the battery. So the device thinks it has an original battery, but it doesn't, and it doesn't even have a temperature sensor on it. So this cell has no protection. And also, I have to mention that 18650 cells have a single layer protection on them. Some of them have a small little circuit on the top that will allow the battery to protect itself, which will work as a two-layer protection on an 18650 cell. But normally, if the 18650 cell is not like cheaply made or fake cell, which this battery is Sanyo, which is a good battery brand, and it's from an old laptop battery. It has little vents. If you can see on the camera, there's little holes on the positive side, and there's a small little vent here. If the pressure inside the battery rises too much, the extra gases that are inside the battery will exit outside the battery from this little vent. And if the battery becomes damaged and has too much gases in it, this vent will completely rip the positive connection and completely disable the battery. So it will become unusable, but it will prevent it from exploding, because these have a metal casing that is thick. So not like these mobile cell phone batteries, which they have a thin layer of metal coating around them, so that if they get damaged, they usually puff up. But 18650s don't puff up. They either explode catastrophically or they prevent themselves from exploding. So here I have a small little project that I power with this small old fake cell phone battery. If I turn on the switch, the LEDs light up like this, and the input of these LEDs are connected to the output plus and output minus on the TP4056. So if the LEDs short out somehow, which is very unlikely to happen, but if it happens, the DW01 will completely cut out the output and will not output a voltage ever again. To break that security or reset that security, you have to connect it to a charger. I also have to mention that I modified this TP4056 on this project, because this battery's capacity is, as you can see, 650 milliamp hours, which is very small capacity, and if I charge it with a non-modified TP4056, which charges the battery with a current of 1000 milliamp hours or 1 amp, it can easily damage the battery or shorten its battery life. So how to do this is, there's a small little resistor on the TP4056 which is called R3 on this board, and normally it comes with a resistance of 1.2K, and you can adjust this resistor how you want. There's actually extra information about this resistor on the datasheet. So as you can see, it says RProg current setting here. RProg kiloohms, 10K, 5K, 4K, 3K, 2K, 1.66K, 1.5K, 1.33K, and 1.2K is the default for this type of board. And it also shows the current in milliamps. So the default is 1000 milliamps, which is an amp, and I replaced the 1.2K resistor on this TP4056 board with a 2.2K resistor. Let me show this close up. As you can see on R3, you can see a small SMD resistor soldered 222. It says 222 on it, which stands for 2.2K in SMD resistors. And if we look at a non-modified board, as you can see, it has a resistor that says 122, which is 1.2 kiloohms on SMD resistor code. And if we look at the RProg table, as you can see, 2 kiloohms is 580 milliamps. But since the resistor that I used is 2.2 kiloohms, it charges this battery at around 500 milliamps, which is suitable for BL5C's charging current. And this RProg resistor not only selects the charging current, but if we go up on the top of the datasheet where this graph is here, there is 100 milliamps starting current on below 3 volts. So if the battery goes below 3 volts, it starts trickle charging the battery with 100 milliamps. But you also set this with the RProg resistor. So if you have a very small battery that you're gonna charge with the TP4056, you can put a 10K resistor on R3 and it will charge it at 130 milliamps. But can we use the TP4056 on a high current project? Yes, we can, because the 8205 MOSFET on here, which switches the battery output and input, can supply up to 5 amps of current, because it has thick pins here, as you can see, soldered on both sides of the chip. And if we go to the datasheet of 8205A, it says it's a dual N-channel enhancement mode MOSFET, and on features it says it can handle 5 amps at 20 volts. So you can use the protection board of the TP4056 at least at 5 amps, so it can protect your battery on a project that can draw up to 5 amps. This is how you safely use a single cell lithium-ion or lithium polymer battery. But what if we wanted to connect these two batteries in series? Which wouldn't make a lot of sense, because since this battery is around 1000 milliamp hours in capacity, because it's from an old laptop battery, the capacity gone down from around 2000 milliamp hours to down to 1000 milliamp hours. If we connect these in series, the cells will become really easily out of balance, and you need to use a balanced BMS board to use lithium-ion batteries that are in series. But I recommend using a single cell on most of your projects, because you can also just step up the voltage with a common voltage step up module like MT3608, and you can easily get around up to 35 volts from a 3.7 volt battery at 2 amps. And other safety measures you can apply on lithium-ion or lithium polymer batteries is don't apply forces on them, and you should store these batteries at around 3.86 volts. This is the storage voltage for lithium-ion and lithium polymer batteries. If you don't store them at this voltage, they can lose capacity over a long time. I also want to mention one thing on the little TP4056 module. Most of the TP4056 chips in these modules are fake. The original TP4056 module is from Top Power and it looks something like this. Here is the Top Power logo and here is the TP4056 text, and this is probably a batch code. But if we look at our TP4056 module, let me focus on the camera, it says 456H rather than TP4056, and it doesn't have the Top Power logo. And you can see the DW01A and 8205A chips too. This TP4056H chip, I've never had any problems using it, and most of the fake chips on these boards are fine. Some of them are optimized for 3.8 volt batteries, which is going to charge your lithium ion or lithium polymer battery a little bit more, at around 4.3 volts, but it shouldn't be a big deal. My recommendation is not to buy this board, but to buy this board instead, because it can protect your battery while charging it. And the only problem with this board is the fact that if you connect a charger while your circuit is running, for example, my circuit is running right now, and if I connect a charger here, the DW01 and 8205A battery protection circuit gets completely disabled, because when you put a charging lead into this, the TP4056 will start putting out 4.2 volts to the battery plus and battery minus points, and the DW01 and the 8205A will probably see this as a healthy battery. Even if there is no battery connected, they can still identify that as a battery and completely get disabled. So if you connect a charging lead and run your project at the same time, the TP4056 chip can become overheated, or if your project shorts out while it's charging the battery and while it's running, your battery can explode or catch fire. And this circuit may not even charge your battery while the project is drawing current from it. So this board is only used for charging the battery when the project is off like this. So I don't recommend connecting any load while your battery is charging. But after the battery is charged, you can safely connect your load up to 5 amps. They solved this issue by modding this module, but I don't recommend changing anything on this module except the R3 resistor, because it can mess with the internals of the TP4056 or the DW01A and 8205A chip, and if these chips get damaged, your battery may not be protected. So I don't recommend, if you're gonna use your project while it's charging, buy something better. Like this TP4056 module is not made for that, and I don't recommend modding it other than the R3 resistor. You can buy specialized BMS boards for this purpose. You can connect the TP4056 on your battery and not use the output pins, or just buy this board instead and connect your battery to an external BMS board. But if you're not going to use your project while it's charging, you can buy this board and safely use it. If you're going to use another BMS board or an external BMS board with your battery, you can buy this. But if your battery doesn't have a BMS board like this, I don't recommend you to buy this module. Buy this module instead. And that's how to use your lithium ion or lithium polymer batteries safely on your projects without hurting them. This is Arduino Atolyem. Thank you for watching. If you found this video useful, please don't forget to like and subscribe. See you on the next video, and stay safe.